Okay, Bismillahirrahmanirrahim. Assalamualaikum. So today we're going to start a new topic under chapter number 3, which is type 1 error and type 2 error. Right. The definition of type 1 error is actually HO, when H null is rejected, right? But we accept the null hypothesis. Sorry, the definition is uh, when the H null is true, but we reject the null hypothesis. So this is what we call as type 1 error. So when the null hypothesis is true and we reject null hypothesis. So this is our decision, and this is the state of nature. Right. So the null hypothesis, the type 1 error is denoted as alpha, right? And the value of alpha is called as the level of the test, right? Second term that we need to know is type 2 error. Type 2 error means when the null hypothesis is false, right? And then we still accept the null hypothesis, right? So this is what we call the second error, right? The second type of error, right? So in this topic, we're going to learn two type of error. First is type 1 error. Another one is type 2 error. So type 1 error means when the null hypothesis is true, we reject the null hypothesis. So we are making a wrong decision lah. So this is a type 1 error. Another wrong decision that we're going to make is when the null hypothesis is false, we accept null hypothesis. So this is type 2 error, which is the wrong decision that we're going to make. So the type 2 error is denoted as beta, right? So type 1 error is alpha and type 2 error is beta, right? So so now look at this one, this table, right? We have state of nature and decision, right? So our decision whether we going to accept null hypothesis or reject null hypothesis. Let me clear this one. So this one should be accept null hypothesis. And then this one is reject null hypothesis, right? So the state of nature, whether the null hypothesis is true or null hypothesis is false. If the null hypothesis is true, then we accept null hypothesis, then we are making a correct decision lah. Another one is when the null hypothesis is false, right? The null hypothesis is false and we reject null hypothesis, so we are making a correct decision. So the wrong decision is when the null hypothesis is false, right? The null hypothesis is false and we accept null hypothesis. So we are making a wrong decision. This wrong decision we call as a type 2 error. Another one is when the null hypothesis is true, we reject null hypothesis. So this is type 1 error. This is also a wrong decision. Right. As we know that the type 2 error notation is alpha. As type 1 error notation is alpha and type 2 error notation is beta. So the power of the test when the null alternative hypothesis is true is 1 minus beta. So 1 minus beta is the power of the test. Right? So beta is the probability of committing type 2 error. So we already know that one. So now, to understand this topic, we're going to look at many example, right, to understand the topic. If we cannot, if we not you looking at the example, we cannot understand the topic very well. So now, look at example number 1. So example number 1, suppose that manufacturer A of a new medication want to test a null hypothesis theta equal to 0.9 and against the alternative hypothesis theta is equal to 0.6. So the hypothesis statement for this example is null hypothesis equal to theta equal to 0.9. The alternative hypothesis theta is equal to 0.6. Right. So in this test statistic is X. So the test statistic that we're going to use is X, and the observation number of success recovery in 20 trials. So what does it mean? It means that it have a probability going to give us number of success in 20 trial. So this is going to be a binomial distribution, and this is the number of success lah, the probability of success, right? So the next statement is he will accept the null hypothesis when 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 X is more than 14, right? When X is more than 14, it's going to accept null hypothesis, right? For example, let's say I can illustrate into a probability distribution. Let's say this is a binomial distribution, for example, right? Say this is 14. So when X is more than 14, right? So this is acceptance region, right? When X is less than or equal to 14, this is your rejection region. This is for example, just for our understanding, right? So our decision criteria for this example is decision criteria for this example. H null is accepted when X is more than 14. Then H null is rejected when X is less than or equal to 14, right? So this is either X is more than 14 or X is more than or equal to 15, right? It's the same. So to solve this problem, the statement asks us to find alpha and beta. Alpha is our probability of type 1 error, right? So alpha is a probability of type 1 error. And beta is a probability of type 2 error, right? So now if we want to find alpha, right? So let's put this way, alpha is equal to probability of type 1 error, which is a probability of reject null hypothesis when null hypothesis is true, right? Because based on the table that we already looked at before, the type 1 error, when the null hypothesis is true, we're going to reject null hypothesis, right? So this is the probability that we want to find. So probability of rejecting the null hypothesis is when X is less than or equal to 14, right? The null hypothesis is true is when theta equal to 0.9, right? So theta 0.9. So this is the probability that we want to find. Since we already know that this problem is a binomial problem, so we want to find probability of X equal to 0 plus probability of X equal to 1 plus until probability of X equal to 14. Right. So the binomial distribution is n choose X, which is for X equal to 0, 20 choose 0, right? And the probability of success 0.9 power of 0, 0.1 power of 20 minus X. So this one, 20 choose 1, 0.9 power of 1, 0.1 power of 20 minus 1 is 19 plus until 20 choose 14, right? Because the last value is 14, and this is 0.9 power of 14, and this is 0.1 power of 6, right? If you calculate this value, you will get 0.0113, right? Right. If you are using a statistical table, by statistical table, right? Since our statistical table measure the probability on the right hand side, so we're going to find the probability of X is more than or equal to 6 lah, right? And probability of success 0.1 and N equal to 20. It will give us the same result, 0.0113, right? So this is how we find alpha. So if you want to find beta, as in this example, ask us to find beta. So beta is equal to the probability of type 2 error, right? So which is the probability of accept null hypothesis when null hypothesis is false, right? So this is the probability criteria for type 2 error, right? If you look at the table, type 2 error is when the null hypothesis is false and we accept the null hypothesis. So this is what we call as type 2 error, right? So now, type 2 error, so when the criteria of accepting the null hypothesis is when X is more than 14, right? And the null hypothesis, theta is equal to 0.6. So this is 0.6, right? So we're accepting the null hypothesis is false, means the alternative hypothesis is true, right? 0.6. So this is a probability condition that we want to find. So it means that if you make a manipulation circuit, so this is going to be X is more than or equal to 15. It's the same with X is more than 14, right? So this one should be, since this is a probability binomial distribution problem, probability of X equal to 15 plus probability of X equal to 16 plus until probability of X equal to 20. Right? So if you are using the statistical, using a normal method, this one should be 20 choose 15, 0.9 power of 15, 0.1 power of 5 plus until probability of 20 choose 20, and this one should be 0.9 power of 20 and 0.1 power of 20 minus 20 is 0, right? So this one should be equal to 0.1256, right? So this is how we find type 1 error, probability of type 1 error and probability of type 2 error, which is beta, right? Are you okay with this one? Right, can we move to the next example? Right. So now look at example number 2. So we're going, in this topic, we're going to do a lot of examples for our understanding. So for example number 2, for Jones political pool, right? So N equal to 15 voter sampled. So we wish to test the null hypothesis P equal to 0.5 versus alternative hypothesis P is less than 0.5. So our hypothesis statement is null hypothesis equal to P 0.5. Alternative hypothesis P is less than 0.5. 5, right? So the test statistic is Y, right? And the number of sample water favoring Jones, calculate, this is a number of sample water favoring Jones. So this is the one of the probability of success. This is the thing that we want to find, the random variable, right? So means that the number of success means number of sample favoring Jones. So we want to find or calculate alpha if the rejection region y less than or equal to 2. So the rejection region is equal to y less than or equal to 2. So this is going to be our critical region, critical value. So now if you want to find alpha, probability of type 1 error, which is a probability of reject null hypothesis when null hypothesis is true, right? So rejecting null hypothesis when the probability of when y is less than or equal to 2. When the null hypothesis is true, p is equal to 0.5, right? So this is the probability that we want to find. So since we know that we have n equal to 15, and this is based on the statement, this is a binomial problem. So we're going to use a binomial distribution. 15, choose 0. So let me put this way. We want to find probability of x equal to 0 plus probability of x equal to 1 plus probability of x equal to 2, right? So this is going to be 15, choose 0, right? And probability of success 0.5 power of 0, 0.5 power of 15 plus 15 choose 1, right? 0.5 power of 1 and 0.1 power 0.5 power of 15 minus 1 is equal to 14, and the last one is 15 choose 2 and 0.5 power of 2, 0.5 power of 15 minus 2 is 13. So this one going to be 0.004. So 0.04 is our type 1 error, probability of type 1 error. Right? Are you okay with this one? So now, if you're okay, we can move to the next example. The next example is example number 3. Right? Example number 3. Suppose we want to find the probability of committing type 2 error in a Gessling experiment. So if the true mu with additive was 25.75 and equal to 30 and sigma equal to 2.5, and y bar, another missing value here, y bar is equal to 25.718, right? So we want to find the probability of type 2 error. Probability of type 2 error is beta. So beta means accepting null hypothesis when null hypothesis is false, right? So this is finding type 2 error. So assume that this is a normal distribution. So we're going to use probability of y bar, the rejection region. So if true mu, right, means the statement says that if true mu, were 25.75, means that we're going to accept null hypothesis when the mu is less than is equal to 25.75. Right. Sorry. This is our critical region basically, and this question is not very complete. But I try to explain. This y equal to 25.718 means that when y is less than 25.718 means this is our rejection region. When y bar is more than 25.718, this is our acceptance region. So acceptance region, we're going to accept null hypothesis, right? Sorry, terbalik. When more than, less than. This is less than, yeah. So when y bar is less than 25.718, then we're going to accept null hypothesis. And null hypothesis is false when mu is equal to 25.750. Right. So to find this answer, probability of y minus mu divided by sigma over square root of n. So this is a normal distribution, less than 25.718 minus 25.750 divided by our sigma is 2.4 over square root of 30. So this one should be probability of z less than this is going to be negative 0.07, and this is going to be 0.4721. Right. So probability of type 2 error is 0.4721. All right. Right. So this is just a type 1 error and type 2 error. So for the next topic is we're going to find a critical region, which is we're going to combine the knowledge of type 1 error and type 2 error to find the critical region. So critical region is a good test procedure. So dia kata dekat sini, a good test procedure is one in which both alpha and beta are small. Means that the type 1 error and type 2 error are small, then we're going to get a good test procedure. So thereby giving us a good chance of making a correct decision lah. When the alpha and beta are small, then we're going to making a correct decision. So it would be reduce alpha and beta by appropriate changing a critical region. If you want to reduce alpha and beta, so we need to change or find the correct critical region. So in reducing type 1 error, if type 1 error is reduced, type 2 error will be increased. So it's a negative correlation, right? So when we increase type 1 and we reduce type 2 error, then the type 1 error will increase. Now, to understand this topic, so we look at that example. So example number 1. Suppose that we want to test null hypothesis that the mean of normal population with sigma squared equal to 1 again is mu naught against the alternative hypothesis is mu1, where mu1 is more than mu naught. Find the value of k is our critical region, such that x bar is more than c, provide a critical region of size alpha 0.05 for a random sample of size n. So now how to solve this problem? So we have a normal distribution problem, sigma squared equal to 1, right? And our n, we don't know the value of n, which is n is equal to n, right? And we also don't know the value of mu naught and mu1. So we only know that when x bar is more than c, so we're going to reject null hypothesis, right? Reject null hypothesis, right? So to find k, right, such that probability of x bar more than k, right, is equal to 0.05, which is our alpha here is 0.05, right? Means our alpha means a probability of type 1 error, right? Right. Probability of type 1 error means I repeating the same thing many times, right? Probability of reject null hypothesis and null hypothesis is true, right? So probability of rejecting null hypothesis is probability of when x bar is more than k and the null hypothesis is true. So means that x bar is more than c when the null hypothesis mu naught. Right. So this is dia kata dekat sini, the statement of hypothesis statement here. Let me put somewhere. Hypothesis statement. So null hypothesis mu naught, right? Mu equal to mu naught. For example, mu equal to mu naught. This is null hypothesis. Alternative hypothesis, mu equal to mu1, right? Where mu1 is more than mu naught. So this is the statement, the information that give to us. So to combine these two, we assume that probability of x is more than k, right? We don't know the value of c. We also don't know the value of mu naught, right? So this one should be probability of z more than k minus mu naught divided by sigma over square root of n. So this is 0.05, right? So to find this value, we don't know the value of n. We also don't know the value of mu naught. We know the value of sigma, right? Sigma square is equal to 1. So this one should be probability of z more than k minus mu naught divided by 1 over square root of n. And this is going to be 0.05. So to find this value k and to value k, right, we need to remove the probability sign and z, right? So we need to convert 0.05 into x value, right? So by looking at the normal distribution table, a normal distribution curve, if you want to measure probability of z more than j, for example, equal to 0.05, so it should be on the right hand side lah. Right, so this is 0.05, so this is j, right? So if you want to find probability of, let's say I'm going to use another color, probability of z less than j equal to 0.05. So it means that you are measuring on the left hand side. So this is j. This is another one. Let me use another. This is basically k, for example, k, right? So by looking at the statistical table, z 0.05 is 1.645, right? Is it? So If you are measuring on the right hand side, it's going to be 1.645. If you are measuring on the left hand side, it's going to be negative 1.645. So this one we are measuring on the right hand side, right? So this one should be 1.645 equal to k minus mu naught over 1 over square root of n. So now, based on the problem, the statement, we can find the value of k, right? So k should be equal to 1.645 divided by square root of n and plus mu naught. So this is the value of k. This is our new critical region. If we want to reduce our alpha equal to 0.05. Are you okay?
Yes.
Right. Can we move on to the next example? Right. So don't worry, this lecture I will upload into YouTube. So later you can revise back in YouTube channel. Right. So now look at example number 2. Right. In example number 2, a random sample of size 8, right, is taken from a normal distribution with unknown mean and variance equal to 40. Sigma square equal to 40. Given the hypothesis statement, null hypothesis mu equal to 15, alternative hypothesis mu is equal to 9. So let the critical region for the test be y bar less than or equal to 12.5. So the question is, this is a rejection region, right? So this is a normal distribution, right? So if we are putting into a normal distribution curve, right? So when y bar less than 12.5, so this is going to be, let me put this way. When y bar is less than 12.5, means that this area is the rejection area. And this area is acceptance area, right? So now, if the following values are observed, means the value is 20, 19, 17, 24, 14, 9, 11, and 15. So what is our decision? So solution. For number 1, we know that the rejection area is when y bar is less than 12.5, less than or equal to 12.5. So when y bar is less than or equal to 12.5, we're going to reject null hypothesis. Right. So our null hypothesis is mu equal to 15. Alternative hypothesis mu is equal to 9. So now, given this value, right? So what we need to do is to calculate the y bar. So what is our y bar? Summation of y divided by n. So 20 plus 19 plus until 15 divided by how many observation? 1, 2, 3, 4, 5, 6, 7, 8. So divide by 8. So this one should be equal to 129 divided by 8 should be equal to 16.125. Right? 16.125. So since y bar calculated is more than 12.5, 50, we're going to accept null hypothesis. So this is our decision. We conclude that what mu is equal to 15, right? We accept null hypothesis, which is mu equal to 15. Right? All right. For the next, for the first question, we already accept null hypothesis. And for the second question is, find the probability of type 1 error, right? And the probability of type 2 error. So to find the probability of type 1 error, we know that number 2, probability of type 1 error is probability of reject null hypothesis when null hypothesis is true. So this is probability of type 1 error, right? And then probability of type 2 error is beta is equal to probability of accept null hypothesis when null hypothesis is false. So this is a probability type 1, type 2 error. Right. Let's start with the probability of type 2 error. So if you want to accept null hypothesis, the critical region is y bar more than 12.5, right? So we know from the distribution curve, when y bar is less than or equal to 12.5, we're going to reject null hypothesis. When y bar is more than 12.5, we accept null hypothesis. So this is probability of y bar more than 12.5. And the null hypothesis is false when the mu is equal to 9. So mu equal to 9. So this is the probability that we want to find. So this is going to be probability of z. So this is a normal distribution more than 12.5 minus 9 divided by sigma is equal to, well, what is the sigma? Sigma squared is equal to 40. So this is going to be 40 over, what is our n, equal to 8. So this is, we are taking square root for everything. Right. So this is based on normal distribution as z equal to x bar minus mu over sigma over square root of n. So this is 8, right? So this one going to be probability of z more than 1.565. So by looking at the table, probability of 1.565 is on the right hand side. So this one is going to be 0.0582. So 0.0582. So 0.0582 is your probability of type 2 error. Right. To find the probability of type 1 error, alpha, let me use another color. So alpha is equal to probability of reject null hypothesis when null hypothesis is true, right? So probability of y bar is less than 12.5, less than or equal to 12.5. When null hypothesis is true means mu equal to 15, right? So this one going to be probability of z less than 12.5 minus 15 divided by 40 over 8, right? So this one going to be probability of Z less than negative 1.118. So probability of negative 1.118 is on the left hand side lah. So this is negative 1.118. So the value is 0.1314. So 0.1314. So this is our type 1 error. Right. Are you okay? Now, let's look at another example, which is example number 3, right? So actually, I have more example. Example number 4, 5, 6, 7, 8, and 9. But I'm going to leave it for you for assignment. Example number 4 until 9 as your assignment. Now look at example number 3. Let Y1 until Y5 denote a random sample from a population with mean mu and variance sigma squared. Right. In testing of hypothesis, a null hypothesis mu equal to 1 and alternative hypothesis mu is equal to 2, the best critical region used is Y bar more than K. Right. If the significant level of the test is 0.05, which is this is our alpha, significant level of the test, which is our alpha, and the sigma squared is equal to 1, we want to find the value of K. Right. So now, here we have the hypothesis statement. Null hypothesis, mu equal to 1. Alternative hypothesis, mu is equal to 2. Right? So, the best critical, the current best critical region is Y bar more than K. Right? Y bar more than K. So, if sigma squared equal to 1 and our alpha is 0.05, right? We want to find the value of K. Find K. Right? To find K, we will use the information that we have, which is our alpha, right? So the information that we have is alpha. Alpha is probability of type 1 error, which is probability of reject null hypothesis when null hypothesis is true. Right? So if you want to reject null hypothesis, which is a probability of Y bar more than K. When Y bar more than K, we're going to reject null hypothesis. Right? The null hypothesis is true when mu is equal to 1. Right? So the probability of Z more than K minus 1, or we can put it this way, K minus mu, so then you can understand well. So K minus mu divided by sigma over square root of n. So it will become probability of Z more than K minus 1 divided by 1 is because mu is equal to 1 for null hypothesis, right? And divide by sigma is equal to 1 over square root of n. What is our n? Our n is equal to how much? They are not specifying the value of n. We are not giving the value of n, right? Sorry, yeah, we are giving the value of n. The value of n are given. So means that y equal to 1 until 5, right? So n is equal to 5. So divide by square root of 5. So this one should be 0.05. So as I thought before, so if you want to find the probability of Z more than J, probability of Z more than J equal to 0.05. So it will somewhere here lah, on the right hand side. So this one, J should be 1.645 by looking at Z 0.05 in statistical table. So K minus 1 divided by 1 over square root of 5 equal to 1.645. So now we can find the value of K, right? So K should be equal to 1.7357. Right. So this is our new critical region. Okay. Right. For the next question, are you okay?
Okay. Okay.
Are you okay? Done? Can we move to the next question? All right. So for the next question, let the sample above show the following value. So y1 until y5, y1, y2, y3, y4, and y5 is 1.4, 1.3, 1.9, 1.2.1, and 1.5. So what is our conclusion? So since the critical region is when y bar is more than k, right? So this is number 2. Rejection region when y bar is more than k. Then our k is equal to 1.7357. So this is our rejection region, right? Means that if this is our normal distribution curve, this is 0, this is somewhere mu, let's say 1.7357. If y bar is more than 1.73, we're going to reject the null hypothesis, right? So y bar is equal to summation of y divided by n. So we need to find the value of y bar for this example. So this one should be equal to 1.64, right? So the y bar is 1.64. So since y bar is less than 1.7357, we accept null hypothesis. And we conclude that mu is equal to 1, right? So this is based on null hypothesis. Okay. All right. So can we move to the next question? Are you done?
Yes.
Right. So the next question is, what is the power of the test? So they ask us, what is the power of the test? So we know from the previous section, power of the test is equal to 1 minus beta. So beta is type 2 error. So to find the power of the test, we need to find the value of beta, probability of type 2 error, which is the probability of accepting null hypothesis, and null hypothesis is false. So to accept null hypothesis, probability of y bar less than 1.7357. 0.1357, right? When y bar is less than k, our k is 1.753, and the mu is false when mu the null alternative hypothesis is true. Mu is equal to 2, right? Based on our statement, we know that the alternative hypothesis is mu equal to 2, and we're going to reject null hypothesis if y bar is more than k. So this is the probability that we want to find. So probability of z less than 1.7357 minus 2 divided by, so our sigma is equal to 1, our n equal to 5. So this one should be equal to probability of z less than negative 0.59. So it will lead us to 0.2776 by looking at the statistical table. So this is our beta. So power of the test, it should be 1 minus 0.2776. So this one should be equal to 0.7224. So it means that we have the power of the test is 72%. All right. Okay. Are you done?
Yes.
Are you okay? Done? So now, question number 4. If it is required that alpha remain at 0.05. So based on our calculation, our alpha is berapa? So dia tak beritahu kan, they said alpha 0.05 lah, right? So we want to remain alpha to 0.05, but we want to reduce type 2 error to 0.1, right? Our current type 2 error is 0.2, 0.2776. So if you want to reduce the type 2 error to 0.1, right, and maintain the type 1 error to 0.05, right? So we need to find a new critical region, and the sample size need to be taken, right? So we need to adjust the critical region and need to adjust the sample size in our sample, right? So now, number 4. So we want to maintain alpha 0.05, which is probability of type 1 error. And we want to change beta equal to 0.1, which is probability of type 2 error, right? So let we begin with probability of type 2 error, right? So beta is 0.1, which is equal to probability of accept null hypothesis when null hypothesis is false. So this one should be, if you want to accept null hypothesis, right, the rejection region is when y bar is more than k, right? So the acceptance region is y bar less than k. So probability of y bar less than k, and the null hypothesis is false when alternative is true, mu is equal to 2. So this one should be probability of z less than k minus 2 divided by our sigma over square root of n is 0.1. So we do know the value of sigma, right? The sigma squared is equal to 1. Based on this example, sigma squared is equal to 1. Where is it? Right. Yeah. So probability of z less than k minus 2 over 1 over square root of n is equal to 0.1. So by looking at the statistical table, right, if you want to find the value of probability of, let's say, z less than j equal to 0.1, so we are looking at the left hand side. So this is the value of j, right? This is 0 from negative infinity to infinity. So j should be equal to, by looking at the statistical table, 0.1 should be equal to what is the value of j? Negative 1.28, right? So this one going to be negative 1.28. So this one, k minus 2 over 1 over square root of n equal to negative 1.28. So leave it k on the left hand side and others value on the right hand side. So k should be equal to negative 1.28 divided by square root of n plus 2. So this is the new k, right? Since we don't know the value of k and we also don't know the value of n, so we leave it this equation as number 1. Right? So next, we look at the value of alpha, which is alpha equal to probability of type 1 error, which is probability of reject null hypothesis when null hypothesis is true. So we want to remain alpha equal to 0.05. So probability of rejecting null hypothesis when y bar is more than k and null hypothesis is true, mu is equal to 1. Right. So this one should be equal to probability of z more than k minus 1, right, divided by 1 over square root of n. So equal to 0.05. So now, if you want to find 0.05 on the right hand side, it should be positive side lah, right, on the right hand side. So this one going to be 1.645. So k minus 1 divided by 1 over square root of n equal to 1.645. So the value of k is equal to 1.645 divided by square root of n plus 1. So this is equation number 2. Right? So we input 1 into 2, right? We input 1 into 2, right? So we will get 1.645 plus 1 divided by square root of n is equal to negative 1.28 divided by square root of n plus 2. So now we can find the value of n, right? So the value of n, square root of n, should be equal to 2.925 and equal to 8.5556, which is approximate to 9. Because the sample size, we cannot leave it as in the decimal point, right? So our n is equal to 9. So now we already know the value of n. We can input the value of n into any equation. So k, let me choose the first equation. K is equal to negative 1.28 divided by square root of 9, right? Square root of 9 plus 2. So k is equal to 1.5957333. So this is the value of k. Right. So are you okay?
Okay.
So now, you want more example or you want to stop there? I have example number 4, 5, 6, 7, 8, 9. Right. So example number 4 is very simple. Right. Let Z1 until Z30 be a random sample of size 30 from a distribution which n which is normal, phi mu is equal to phi and sigma is equal to 4. Test null hypothesis phi equal to 1, alternative hypothesis phi is equal to 0, and the rejection region Z bar is less than or equal to C is a critical region. So we want to find C, right? So this is very simple, right? You want me to show or you want it as assignment? So let me show you this one. So the hypothesis statement, right? So null hypothesis phi is equal to 1. The alternative hypothesis phi is equal to 0. And the rejection region is Z bar is less than or equal to C, right? So if you want to maintain alpha 0.05, we want and find the value of C. So our N is equal to 30, based on the value of random sample. Right. Based on alpha, probability of reject null hypothesis when null hypothesis is true, right? So the rejection region probability of Z bar less than or equal to C. And the null hypothesis is true when phi is equal to 1. So this is 0.05. Right. So 0.05 on the left hand side, it should be negative 1.645 equal to Z. Sorry. So let me put this way dulu. Baru you faham. So probability of Z less than C minus phi divided by 1 sigma over square root of n, 0.05. So this one should be negative 1.645 because this is measuring on the left hand side, right? So C minus phi is equal to 1 divided by sigma. What is our sigma? Sigma is equal to, do we have the value of sigma? The value of sigma is given on the first statement kan. Mu is variance equal to 4, right? So sigma should be equal to 2 divided by square root of 30, right? So C should be equal to we bring this one over there and plus 1. C should be equal to 0.3995. So this is our C. Right? So this is A. To find next question is compute the power of test if the alternative hypothesis is true. Use value C obtained in A. So we are using C that we obtained in A. We want to compute the power of the test. So the power of the test is 1 minus beta. So first we need to find the value of beta lah. So the value of beta is probability of accepting null hypothesis when null hypothesis is false, right? So the rejection region, the initial rejection region is Z is less than or equal to C. So now when we want to accept null hypothesis, probability of Z more than C. Z bar more than C, and null hypothesis is false when phi is equal to 0. Phi is equal to 0. When the null hypothesis is false, we accept alternative hypothesis. Right. So this one should be equal to the probability of Z more than C is equal to 0.3995 minus 0 divided by 2 over square root of 30. Right? So this one should be equal to probability of Z more than 1.09, which is also equal to 0.1379. So our beta is 0.1379. So the power of the test should be 1 minus 0.1379. So this one should be equal to 0.8621. Right. So example number 5, I want you to do by yourself, right? So wait. Example number 5 is quite hard. Example number 6 is very easy. Example number 7, okay. So which example you want me to show, or you want all these example as your assignment? Okay, let me show you example number 5 lah. Right. So now example number 5, before we end our session, we look at example number 5, and I leave it example number 6, 7, 8, and 9 as your assignment. You will put your assignment into a flip grid. So you can do it after this lecture. So make sure you submit before 6 o'clock, right? So example number 5, let y1 until y30 be a random sample of size 30 from a normal distribution with mu equal to 3 and sigma is equal to theta, right? And test null hypothesis theta is equal to 1 against theta equal to 3. The best critical region is y minus 3 squared more than C. So we want to find C so that the significant level alpha is 0.05. So now the hypothesis statement is null hypothesis theta equal to 1. Alternative hypothesis theta is equal to 3. So our rejection region, right? Summation of yi minus 3 power of 2 is more than C. I equal to 1 until 30. Right. So if you want to find C, so our alpha is we want to maintain as 0.05, which is the probability of rejecting null hypothesis when null hypothesis is true. Right. So this one should be probability of summation of yi minus 3 squared more than or equal to C, right? When the null hypothesis is true, theta is equal to 1. So this is going to be 0.05. So now, if you're looking at this value, this is actually, let's say dia kata dekat sini Y1 until Y30 is a normal distribution kan. Remember chapter number 1, when yi is a normal distribution with mean is equal to 3 and variance equal to theta, we know that yi minus 3 divided by square root of theta is a normal, standard normal distribution with mean equal to 0 and 1. And when we take a square, summation of y minus 3 squared divided by theta, we square this value. Right? Remember chapter number 1, normal distribution, taking a squared normal distribution, it become a chi-square distribution with 1 degree of freedom. Right? So this one will become a chi-square distribution with n equal to 30. Right? If I equal to 1 until 30, right? So now we have a chi-square distribution, right? When chi-squared 30 degree of freedom and alpha 0.05, right? We're going to reject null hypothesis. So this is going to be 0.05 and this is going to be 43.773, right? So then from here we know that the value of C is equal to 43.773. Right, very simple, right? So the next question, B, we want to compute the power of this test if the null alternative hypothesis is true. Use the value of C obtained in A. So B, so the power of the test, right? Power of the test is equal to 1 minus beta. So beta should be equal to probability of accept null hypothesis when null hypothesis is false. So to accept null hypothesis, when the probability of summation of yi minus 3 squared is less than or less than C, and null hypothesis is false when theta is equal to 3. Right. So to solve this problem, right? So if you put summation of yi minus 3 squared divided by theta, right? It should be lead us to a chi-square distribution, right? With 30 degree of freedom, right? Because n is equal to 30, right? Is less than, our C is equal to 43.773 divided by theta. So this one should be probability of a chi-square distribution with 30 degree of freedom, right? Less than 43.773 divided by 3, which is our theta is equal to 3. So this one should be equal to probability of chi-squared 30 degree of freedom less than 14.59110. So this one should be equal to, if you put like this way, right? We want to find the probability, this region, the chi-squared 14.5910. So we want to find this region. Right, this is going to be your beta. Right. So this one should be 1 minus 0.99, which is equal to 0.01, right? So beta is equal to 0.01. So power of the test should be 1 minus 0.01, right? Should be equal to 0.99. So this is the power of the test, right? It's quite hard, but still okay. All right. Okay, example C, I will show you example C because this is not a normal distribution. This is a Poisson distribution, right? So a random sample of x1 until xn of size n is drawn from a Poisson distribution with mean equal to lambda. Suppose that summation of xi is more than or equal to 10 is the best critical region for testing null hypothesis lambda equal to 1 and alternative hypothesis lambda equal to 2 or the sample size n equal to 4. So now they ask us to find the probability of type 1 error. So the probability of type 1 error, very simple, right? But before we go to the probability of type 1 error, we need to know X is having a Poisson distribution, right? Right. The hypothesis statement is null hypothesis lambda is equal to 1, alternative hypothesis lambda equal to 2. So we want to find the probability of type 1 error, probability of reject null hypothesis when null hypothesis is true, right? So to reject null hypothesis, probability of summation xi more than or equal to 10. So this is the rule to reject null hypothesis. And null hypothesis is true when lambda is equal to 1, right? So when X is a Poisson distribution, right? We can also use Poisson distribution when lambda when n equal to 4, but we can also use approximation, normal approximation to Poisson distribution. Let's say I using n is a normal distribution with lambda equal to mu and sigma also equal to mu, because Poisson distribution mean is equal to standard deviation or equal to variance, right? In a sampling distribution, right, n normal distribution, mean is equal to lambda and lambda is divided by n, right? This is for standard error for sampling distribution, right? So now if you want to convert, you want to do a normal approximation, right? I'm using a normal approximation using normal approximation, right? So P summation of xi divide by n, right? Because we are measuring this one is more than or equal to 10 over n, because this is x bar, right? We are measuring x bar. So when lambda is equal to 1, so this one should be probability of x bar more than or equal to 2.5 when n is equal to 4, right? 10 divided by 4 is equal to 2.5 and lambda is equal to 1. So this one, wait, So this one should be the probability of Z more than or equal to 2.5 minus 1, right? Right, let me put the equation first. Probability of Z more than or equal to X bar minus mu divided by sigma over square root of N. So this one should be probability of Z more than or equal to 2.5 minus 1 divided by 1 over square root of 4. So this one should be probability of Z more than or equal to 3. So this one will lead us to 0.00135. Are you okay?
Okay.
Yes. Yeah.
Right. I think I will leave it example number 7. Example number 8. So in example number 8, notice that the critical region is x square, summation of x square. So the best to solve this one, you need to convert this value to a chi-square distribution, right? And example number 9 is quite straightforward, right? Right, you need to use some let me show you example number 8 and example number 9, right? Is actually, I think it's quite hard for you to solve, but I will leave it to example number 8 lah. I show you example number 9, right? The last example for today. So example number 9, are you okay?
Okay.
You want me to show example number 8 and 9?
Yes.
Both.
Yes.
Yes.
Right. But I will show you example number 9 first. Right, example number 8, I think you can solve it by yourself because you can refer to example number 5. Right. So now look at example number 9. Example number 9 is quite hard to solve, but it's not that hard. Very simple. The continuous random variable x only takes the interval 0 and 1. The null hypothesis is x has a PDF FO F naught given by F naught x is 2x1 minus x, where x is between 0 and 1. The alternative hypothesis is 2x, where x is between 0 and 1. So a single observation is to be taken on x, and the suggested test procedure is to accept null hypothesis unless the observation is greater than a, then a constant c, right? So the value of c is to be chosen as to minimize the value of p, where p is equal to probability of type 1 error plus probability of type 2 error. So determine the value of c and p. So now, this is very tricky, right? So to solve this problem is not that hard, right? So first you need to define the hypothesis statement. So our hypothesis statement is null hypothesis, which is f naught x equal to 2 multiplied with 1 minus x, where x is between 0 and 1. The alternative hypothesis is f1 x, which is 2x, x is between 0 and 1. Right. So our critical region is accept null hypothesis if xi is less than c, right? A single observation to be taken on X suggested to proceed to accept null hypothesis unless the observation is greater than a constant C. So we're going to accept null hypothesis when the xi is less than C, right? So another way is we're going to reject null hypothesis if xi is more than or equal to C. So if you want to find a type 1 error, probability of type 1 error is actually the probability of reject null hypothesis when null hypothesis is true, right? So this is a probability of xi more than C when null hypothesis is true is f naught x equal to 2, 1 minus x. So f naught is between 0 and 1. So to find this probability value, so we need to do integration lah. So we need to integrate from C to 1 because the range of f naught is from 0 to 1. So we integrate from C to 1. So this is 1 minus x with respect to x. So this one should be 2x minus 2x squared divided by 2 from C to 1. So this one should be equal to 1 minus 2c minus c squared. So this is going to be equation number 1. And the next step is we want to find beta, probability of type 2 error, which is equal to probability of accept null hypothesis when null hypothesis is false, right? So we accept null hypothesis when the probability of xi less than c, right? And the null hypothesis is false. We accept alternative hypothesis, which is f1x equal to 2x. And the range of 2x is from 0 to 1. So then we're going to do integration from 0 to c because c is the largest value, 2x with respect to x. So we're going to get x squared from 0 to c, then we're going to get c squared. So c squared is our equation number 2, right? So now, based on the question, they tell us that the P is equal to probability of type 1 error plus probability of type 2 error. So probability of type 1 error is 1 minus C squared. And probability of type 2 error is C squared. So we need to plus these two values to get P, right? So P is equal to probability of type 1 error plus probability of type 2 error. So it's going to be 1 minus 2c plus 2c squared plus c squared. Sorry, 2c squared pula. It's going to be 2c minus c squared plus c squared. So this one should be equal to 1 minus 2c So minus C plus C, it should be equal to 0 lah. So this one should be equal to, P is equal to 1 minus 2C. So to find the value of C and the value of P, we need to minimize the value of P. So we're going to take a differentiation with respect to C. So we're going to minimize the P by differentiate P with respect to C, right? So we differentiate P dP with respect to C is equal to dP d dC 1 minus 2C. So this one should be equal to how much? So should be equal to 2. Negative 2. Is it? I think I made a mistake for this one, right? Should be 1 minus 2C plus C squared, I think, right? So this one should be equal to 1 minus 2C plus C squared plus C squared. So this one going to be not this one. So it should be 1 minus 2C plus 2C squared. Right. So then baru kita akan nampak dia punya the value of C and P lah. But this one we cannot see the value of P and C. Right. So we differentiate P with respect to C. So we will get dP with respect to C dC 1 minus 2C plus 2C squared. Right. This one should be equal to negative 2 plus 4C. Right. To minimize this value, dP and dC divided by dC should be equal to 0. Right. So negative 2 plus 4C equal to 0 and C should be equal to 1 over 2. Right. And then it will make sense lah. And we substitute the value of C into P. P is equal to 1 minus 2C plus 2C squared. So P should be equal to 1 minus 2, 1 over 2 plus 2, 1 over 2 squared. So this one should be 1 over 2. So we solve the problem. So example number 8, you do it by yourself and put it into a flip grid before 6 o'clock today, right? I already create a flip grid and your group B already done it, right? They already done it in example number 4, 5, 6, 7, and 8. Yes, 5, 6, 7, 8, 9. So 5 example. So what you need to do is just example number 7, example number 8, these 2 example only. Right? You just do 2 example in the flip grid. Example number 7 and example number 8. So till now, do you have any question?
Sir.
If you have any question, you can ask now.
Sir.
Or else we're going to end this session, and the next lecture going to be a Neyman person lemma, still under finding critical region, the most powerful critical region. Right. So I think that's all. Thank you very much, and Assalamualaikum.
Sir. Sir. Excuse me.